Hello students, so we've come to the last part of this lesson package for finding equations of a straight line, and that is finding the y-intercept value. So in this part of the lessons, finding the y-intercept values, we're just going to find the y-intercept using algebra, all right? And then we're going to use verify the results that we obtain for the y-intercept value graphically. So supposing I'm given a point that have x coordinate 2, y coordinate 7, and given gradient 3. So with this information, how can we use it to find the y-intercept value? So first of all, we need to remember that the general form of a straight line equation is y equals to mx plus c. All right, it's very important to remember this. Y equals to mx plus c. M represent the gradient of the line, C represent the y-intercept, and X and Y represent the values of any point that lies on the line. Any point that lies on the line. A line has many points. All right, so we're just going to use this point called X coordinate 2, Y coordinate 7. So what we're going to do that, we're going to substitute your Y to be 7, okay? Your X to be 2, the gradient to be 3. And substitute into y equals to mx plus c, you have 7 equals to 3 times 2, 6 plus c. So minus 6 on both sides, you get c equals to 1. So for this particular straight line with gradient 3, okay, and this particular point, 2, 7, your y-intercept value is c. So let's look at graphically to see if you are correct. Yes, okay, it matches. So whatever you have done algebraically tallies with what we can see here graphically. Let's try another one. Supposing I have a line that has gradient 6. And on this line that's gradient 6, I have a particular point that passes through this line. It must be a point that lies on the line. Okay, it cannot be any other point. It must be a point that lies on the line. So I'm just going to say that, oh, on this line that have gradient 6, I have this particular point that lies on the line. So this point is -2 and 0, let's say. Okay, so I'm going to substitute y coordinate to be 0, x coordinate to be 6. X coordinate to be -2, gradient 6. So I have 0 equals to -12 plus c. So to find c, what do? I add 12 to both sides. So I have c equals to 12. Let's look at it graphically. Oh, hang on, the diagram. Okay, never mind. Let's use something else that I can actually show you graphically lah. Okay, right. Let's use this one. It's better. All right. So substitute gradient to be 3, x to be -2, y to be 0. Okay, so the gradient is y-intercept is 6. The y-intercept is 6. See? Graphically is 6. Okay, let's use another point. Supposing gradient is -4. Okay? And then let's have a point called 3, 1. No, yes, 3, 1. Oh, I cannot show you 3, 1. Okay, never mind. Let me show you. Okay, right. This one can show. All right. So I'm going to substitute your y coordinates to be -5. This is your y coordinate value, right? -5. Gradient is -4. X coordinate is 3. So you have -5 equals to -12 plus c. So c will be add 12 to both sides. So it's -5 plus 12. -5 plus 12. So c is 7. Yes. Graphically, it shows that c equals to 7. Okay, so to summarize, to find the y-intercept value, okay, you need to know the gradient of the line and one point, just one point that lies on the line. And with that, you substitute into your y equals to mx plus c, you can find your y-intercept value. And that's all, folks.